All right.
Awesome.
Now, this week we're going to be covering GFCI Protection for Boatyards and Marinas. And before I get started, this was sent to me, and this was some audio from Ryan Jackson. And uh, I'm I'm just going to say right now I disagree with what he says, and I'm going to show and explain why I disagree with what his interpretation is. So let me go ahead and play this audio so everybody can hear it, and then we'll go through and look at the sections and see if what he's saying is correct.
Other outlets. Outlets that do not supply shore power must have GFCI protection if they're supplied by branch circuits rated 150 volts or less to ground, 60 amps or less, or 100 amps or less if it's three-phase. All right, so you've got ground fault protection of equipment for the boat. You have GFCI protection for everything else. So here's my regular old receptacle. We would just follow the typical rules in 210.8b. It's outdoors, it's got to have GFCI protection. But even if that rule didn't exist, this rule says, listen, outlets that don't supply shore power still have to have GFCI protection. Now, we have to be careful with the word outlet in this section because it doesn't say receptacle outlets, it doesn't say lighting outlets, it just says outlet. Remember that an outlet, as defined in Article 100, is a point on the premises wiring system where current is taken to supply utilization equipment. So it's not just receptacles that require GFCI protection. That would include lighting outlets as well. So if I have luminaires on my dock, on my boatyard facility, I've got to have GFCI protection for those as well. If I have hardwired equipment, remember hardwired equipment terminates at an outlet where the hardwired equipment meets the premises wiring, that's the outlet. So it's not just GFCI protection for receptacles, it's GFCI protection for just about everything that's on that marina or boatyard.
Oh yeah, everything, man. Just everything. Just
Okay.
GFCI everything.
First, I wanna bring a point up here. He says at a point where it receives its supply is the outlet, and then he says at the receptacle, like if you were cord and plug connecting it. Well, first of
Right.
all, a receptacle is a device. It's not an outlet. There's a reason that we have a definition for a receptacle outlet, which is the box, and then you have a definition for a receptacle. The outlet is the box. Okay. And
Yeah.
that's why these terms are going to matter when we're looking at this. He's making a blanket statement that anywhere that you just pick up current, that's an outlet. That's not correct. And
Yep.
I've been saying this over and over. And this particular section here that we're dealing with that deals with the ground fault protection of equipment and GFCI for personnel protection. They've got them separated here, and they're specifically calling out receptacles. And the reason they are because a receptacle is a device where it's receiving its current, but the receptacle outlet is the box. That's where the outlet is. Okay,
Yep.
it's not the receptacle; it's the outlet box, and that's where your port cord and plug connected. Matter of fact, if you go look at Article 316, the very first word in there that deals with all your different boxes and everything, it says outlet.
Oh,
Okay.
you're talking about 314.
I mean 314, Article
Yeah.
314. I'm sorry.
Yep.
Now, let's look at the section, see what it says here. It says, for other than floating buildings, ground fault protection for docking facilities shall be provided in accordance with 555.35A through D. Okay.
Yep.
So if you look at A is where we deal with a feeder, and it says listed ground fault protection of equipment rated not more than 100 milliamperes shall be provided for feeders installed on docking facilities. Coordination with downstream GFPE shall be permitted at the feeder overcurrent protection device. Okay, now,
Right.
first of all, unlike what he said before, he says a feeder, I could, like if I was going over and hitting a fusible type disconnect, and then I go to a single motor, he says that's a feeder. That's not correct either.
Yep.
That a feeder, I've already showed that. is where you go to 2 or more items. That's when you're taking a feeder. So in other words, if I'm going over there and I'm going out to a dock and facility out there, where I'm going to have a whole bunch of different boats, and I go out there with a feeder to a panel board. That panel
Yep.
board's that's the feeder going out there to that panel board. Everything
Yep.
that leaves there, unless I'm feeding 2 or more items, I'm feeding a single item going out there, and that's going to be a branch circuit. Okay,
Yeah,
no
and
matter
there was
how I set it up.
yeah, and there was another thing that he was incorrect on, and I don't know if it was in that clip, but there is devices out there that can be dialed down from 100 milliamps to 4 to 6 milliamps.
Sure,
He
there
was
are.
saying that's a Class A device. That is not a Class A device. If it has a dial on it and you can dial it, it is not a Class A device. That is a Class E device. So
Sure.
that
Now,
was another incorrect statement.
now watch this. This is interesting. He, if you look at B1, it talks about receptacles providing shore power. Now, he already made the statement, I've got a receptacle that's out there. He's saying, you're cord and plug connecting something. That's an outlet. Therefore, I need to provide Class A protection. Basically, everything is considered an outlet. It shouldn't matter what this says right here because he says it's an outlet anyway, no matter what I go to. Well, right
Yep.
here, they're telling you receptacles. All right. That means I'm
Yep.
going to be cord and plug connecting something. Is that correct?
Yes, sir.
Okay. And it says, if I'm going to shore power, it says listed ground fault protection of equipment not rated more than 30 milliamperes shall be provided for receptacles and installed in accordance with 555.33a. And that's where if you already provided upstream with a feeder, you're okay, right? And then you
Yep.
can dial it down whatever you need to match it. And if I go back and look at 555.33a, it says it will not be rated more than what? 100 milliamp. So that ties
Yeah, and
into what you were just saying.
yeah, there are devices out there that you can dial from 100 down to 30, and he was saying, well, you could dial them down to 4 to 6, but I've already ran this through with some pretty top people in the industry, and they basically say that just because that device can dial down to 4 to 6, that does not make it a Class A device. That's still a Class E device for equipment, regardless if you could dial it down to 4 to 6. It's
Sure.
not doesn't change to a Class A device.
No, it doesn't. And then it talks about outlets for other than shore power. And it says outlets supplied by branch circuits not exceeding 150 volts to ground and 60 ampere single phase and 150 volts or less to ground. It says here 100 amperes or less, three phase shall be provided with GFCI protection for personnel. Okay. Now, that is where you're going to be setting up, just like I do for shore power. These are going to be cord and plug connected type devices.
Right.
Okay. This is not going to be something that's hardwired. And that's where the problem starts coming in. And that's why I
Yep.
say this also. If it is the case, like he's saying, right there where it receives its supply, there would be no need to have a definition for a receptacle outlet because you've
Yes, sir.
already stated that the receptacle is where I'm picking my point up, not at the outlet, but at the receptacle, which is a device. And if I'm hitting a device, that is where I'm cord and plug connecting, and I'm taking and I have personnel that has interaction at that point around a wet location. If it's hardwired, the personnel doesn't have uh, 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 any type of
Interaction.
interaction with it.
Yep. I
Okay.
agree.
Now, let's go a little bit further. Then, if you go in and you look at this, it talks about the receptacles and how you mount them and everything. And when you come down and you start looking at the different things, it talks about the enclosures for shore power receptacles. And look at
Yeah.
here, receptacles intended to supply shore power to boats shall be enclosed in listed marina power outlets. Enclosures listed for wet locations or shall be installed in listed enclosures protected from the weather. The integrity
Right.
of the assembly shall not be affected when the receptacles are in use with any type of booted or non-booted attachment plug caps inserted. Now, let me ask you this. They're telling you you're going to be plugging that in. And you've got your
Yep.
shore power set up there, and they're telling you you got to have a listed marina power outlet. Now, why all of a sudden, if I have the equipment that's plugging in there and I'm providing the GFPE for that, why wouldn't I need GFCI protection also?
Right.
It's a receptacle, isn't it?
Oh yeah.
That that's my whole point here. And then if you look at the branch circuits in Pren 3, what does it say? Each single receptacle that supplies shore power to boats shall be supplied from a marina power outlet or panel board by an individual branch circuit of the voltage class and rating corresponding to the rating of the receptacle. Well,
Right.
looky there. You just told me that when I go over there and I'm picking up uh, uh, my connection there to a receptacle, I that's an outlet, and I've got to have GFCI protection. So is he going to say not only do I need GFPE, but I also need to have GFCI protection for the outlet that's out that I'm plugging into for the shore
Yeah,
power?
that see, and that's pretty much my argument. We've actually made this argument before with EBSE because EBSE says there's protection for personnel, but it's not Class A, and so that's where you run into problem when they're saying you have to have Class A ahead of the Class B, which
Mm-hmm.
the whole thing is they don't tell you what class it is on the manufacturer instructions because it just says personnel protection for it says personnel protection provided. Now, I did some research on a little bit more on this EBSE stuff. Dude, there's so much safety devices and like they have a little pin connector in there that basically it has to make contact with the vehicle before it actually discharges energy. So
Sure.
there's so much like safety stuff in there that there's no reason that you have to, provide Class A for that upstream uh, outlet that they say exists. And another interesting thing that I'll just tell everyone, all the viewers out there, is that the individual branch circuit, if you go look in the definition, it says connects to utilization equipment. So technically, you start at the breaker or fuse, final overcurrent device, and ends at utilization equipment. There's
Sure.
nowhere does it say it ends at an outlet.
Yeah, and I'll take it a step further. And nobody will answer this. But don't worry, there's a lot of proposals that are going to be coming from me. If you go look at the definition of a branch circuit, it says it can supply what? An outlet or outlets. Now, if I can go to just an outlet, then that's an individual branch circuit. Okay, because you're supplying one piece of equipment. Why did they feel the need to go in and say for an individual branch circuit, being very specific that that goes to what? Utilization equipment. The
Yep.
reason is because it's hardwired. Now, if you go back and look at the definition of a branch circuit, it says it can go to an outlet or outlets. And if I just go to one outlet, it can just be an individual branch circuit. But if you're going, or if you want to call it an individual branch circuit, but another interesting point, somebody said, well, if you go look at 422.16B43 and you go over there and pick that up, it says you can have an individual branch circuit. And I said, exactly. I said, but you left out the most important part. What is that individual branch circuit feeding? It says a receptacle. And a
Yep.
receptacle is going to be put where? At an outlet, which is the box. And that's when
Yep.
your cord and plug connected. So when they are clarifying some of these individual branch circuits, they're basically taking it from the definition of a branch circuit and they're basically telling you you got to have a receptacle there. Otherwise, they don't mention receptacle because you're connecting to what? Utilization equipment.
Yeah.
Okay,
And
which
like
is hardwired.
when you look at like these window units, somebody mentioned it. One of the J Dubs at the job site. Really appreciate shout out to you, brother. Um, he mentioned like, why does a window unit have to have an individual branch circuit? And the whole thing
Sure.
is, it's like they're only drawing like 5 amps. Why can't it? It's not continue. Like it could be continuous, but the thing is that if you have that set on like a thermostatic control, there's not a guarantee that that AC unit's gonna run for 3 hours or more. You
Yeah,
know.
and plus you go look at it's a good point. What does a window unit have there? It's got to have GFPE,
Yeah.
and and the equipment. If the equipment's having a problem, that's what's going to protect you. Why? You got the AC unit. It's at a window. It's outside. It's getting rained on and everything. Why don't I have GFCI for that receptacle there?
Yeah.
I mean, you just, and that's what I'm saying. There's certain equipment they tell you to have GFP protection, okay, and it's the equipment that's providing the protection. And I'll add another point. Co-making panel 2 went in, and then they come back after the fact and said, "Oh yeah, the AC unit, there's an outlet there, and you got to have GFCI protection." Well, wait a
Oh,
minute.
you
Wait,
forgot. You forgot the language. The charging language. Most likely, there's an outlet there. That's
well,
what they said. Most
that's
likely.
there's no most likely. There's not one there, but I'll take it a little further. They didn't have the technical merit to even make that kind of change. There were no deaths or anything from the AC unit. And I've heard them come in and say, well, the AC manufacturer needs to get their equipment fixed. No, the AC manufacturer doesn't have to do anything. Their
Yeah.
equipment is designed by UL, and it has a listing and labeling on it. Matter of fact, the new standard that's coming out the 1st of January 1st, 2024, they got it down now to where it's 10 milliamps. That still is not going to fly for GFCI protection. Matter of fact, if you go in and look at the substantiation that was given during the Standards Council process review, the Standards Council completely rejected the TIA from the co-making panel 2 wrote, and co-making panel 2 rejected what the task group did, and they're basically telling you that's not going to happen. It's not.
Yeah.
Their equipment's not going to work that way. Well, then the Standards Council said, "Now wait a minute." They did all this stuff down in Houston and did all these different AC units. They actually provided substantiation. Co-making panel 2 didn't provide no technical merit at all. So basically, I feel like everything they did to 210.8F and then started saying this, they did something that wasn't correct. And I will tell
Sure.
them that I'll tell them to their face. You did not have the technical merit to make that change. And
Well, yeah, and just to let everyone know, the equipment was not designed by UL, but the equipment manufacturers are actually using a UL standard. So UL has all these different standards about how the compressor's wired, how the
sure they do.
how the contactor's installed, what it's tapped to, what leakage current, where the leakage current goes to. And this whole leakage current thing, I believe, is an afterthought that they thought this is going to save us, and we're going to be able to prove our argument that this equipment has leakage currents. Well, then what do they run into? Freak drives. Oh man, freak drives. Oh man, freak drives don't have leakage current. But what the variable frequency drives are doing in these pieces of equipment is they're basically ramping your motor up slow. So that's where you get your high efficiency units. So what's happening is you don't have that solid inrush of like 30, 40 amps that a lot of times what we have to do like tens on a 50. We don't have that tens on a 50 kind of inrush. So what they're doing is basically that variable frequency drive is basically like a dimmer for your AC unit where it's turning it on, but it's turning it on slow. And when it does that, the Class A device freaks out and trips because it sees that dimmer action actuating and it doesn't know what's going on because it sees an imbalance between the grounded and ungrounded conductors, or actually the grounding and the ungrounded conductors, and then the GFCI activates, thinking that there's a problem when it's not, just the AC and it's going through its cycle of ramping up to turn power on.
Sure.
And so this has gotten to be a problem in a lot of places. I saw something earlier, James. I thought it was 109 down there where you're at today.
It's hot.
But I don't think I'd be wanting my AC to trip. And then I was talking to some people today at the gas station that had a Tesla, and they weren't getting gas; they were just at the gas station. But I was like, "Yeah, how would you feel if your Tesla charger tripped while you're sleeping?" And yeah, they didn't really like that. So that kind of thing. It's pretty funny. Like the look of horror was like, "Why would we put it on a GFCI?" And I was like, "Well, there's certain people out there that says you have to, or else you're killing babies." But the whole thing is that I do not want to downplay the tragic incident that happened to Von Pergo. That was very tragic. There's a lot of. I feel that this whole thing should have been dealt with a lot earlier. If this child died in 2007. For them to come out in 2020 and put it in, I just think is not right. There's not been a hazard. I could see if there's been a hazard since 2007, and there's been 2007, 2014, even if there was just two, and they say that there's two, there's three, there's four, whatever. These guys were HVAC techs working on an energized, not locked out, tagged out.
That's right.
You can't. The code is that was not what the code is for.
That's right. And I'll say this: the incidents they referenced had nothing to do with the equipment. It had to do with improper wiring and improper maintenance, and that does not give you the right to make a change and require something when the equipment was not at fault. And what they did, in my opinion, was underhanded to say that was the reason. And there's going to be some clarification coming in 2026. And, I'm putting in, you need to delete the definition for an individual branch circuit, the definition for a motor, the definition for a general purpose branch circuit, and the definition for multi-wire branch circuits. And the reason you need to delete that is because everything has an outlet anyway, and a branch circuit already covers it. Okay. There's a reason those definitions are in there. And for them to come in and say, oh, well, those definitions, you got to use the definition of a branch circuit with that. No, you don't, because it's already an outlet anyway by y'all's thing. And let me say another thing. Ryan's saying, oh, where the wiring method connects to the equipment, there's where the outlet is. You're going to tell me I have an outlet that's just free floating in an infinite space there? Yeah. But yet I need to clarify what a receptacle outlet is, for instance. Yeah. There's already an outlet. Why do I need to clarify that? This is picking and choosing to use your argument. But I'm going to regress on that for a minute. I want to go to this next part.
Dude, did I tell you that I put one in for individual branch circuit? Because individual branch circuit's the only definition that doesn't say outlet. So what I submitted was to add the term outlet to individual branch circuit and then say that's what the utilization equipment connects to. Mm-hmm. And I don't think they're going to like that one.
Yeah, and I want to put another part on this. Also, it's interesting. When you're looking at the receptacle, that shore power receptacle is, when you look at 4A, it tells you that receptacle is rated at 30 amps and 50 amperes and shall be of the locking and grounding type. That means it's going to lock in. There's a reason that the receptacles are designed a certain way. And and basically what they're telling you is you're not really going to be as the owner of that slip, cord and plug connecting that, you're going to be doing that to the unit that's there, that's providing the shore power. And that's the reason that there's no GFCI protection. You know what amazes me about this? If I'm plugging into that receptacle, why are they so specific, saying all my other receptacles have to have Class A GFCI protection, but when I go to the receptacle for shore power, it doesn't? But yet I'm going to allow to have my GFPE protection at the equipment or the feeder upstream.
Yeah, and that's a good point, James. And kind of in layman's terms for all the people watching, what we try to do is we try to selectively coordinate this for the safest install possible. So
Sure.
what we're doing is we're doing the 100 milliamps upstream on the feeder. Then that's going to a 30 milliamp, and then what we're doing is we're going from the 30 milliamp to the 10 milliamp.
That's
So
right.
in essence, you have these pieces of equipment GFCI protected in some way, actually GFPE protected, but
Right.
you have Class A protection at your locations that are for protection for personnel. You have your shore power that's for protection of equipment, which just to make people understand, protection of equipment means if there's a problem with that equipment, that's gonna open that overcurrent device prior to human contact.
Sure.
So the Class A device is based on human let go. So if you have a lot of human interaction with something, I think, yeah, cool, it's probably a good idea to have Class A protection. Like, one of the good examples of this is a dryer. And I've always argued this with a lot of guys with why isn't a dryer outlet required to be Class A protected? Well, under 2023, 210.8D as specific appliances. There was a lady and her daughter that were both killed on a dryer. And I guess what happened was, I don't know if it was the daughter or the mom, they got hung up on the frame of the dryer. The daughter tried to save her or whatever, and they both died. To me, that's a good change. That right there is like, yes, that dryer has a ton of human interaction. I've seen kids actually jump inside the dryer before. You know, I think that is great to have Class A protection for that. You have a box on the side of your house that nobody ever touches, and you're saying that that needs the same rules as that dryer. So that's where I think this is kind of ridiculous.
Sure. I'll take it a step further. When they go to the receptacle other than shore power, Class A protection, and we agree that the receptacle is a device, right? Okay.
Yep.
Now, if I have a breaker trip, why don't I have upstream at that breaker? Because you got a panel board that's got a feeder going out there to it. Why doesn't it have GFCI protection? That's a device, isn't it? And that's my whole point. You cannot just pick and choose where you want to classify the receptacle, and
Right.
that's why I've been trying to say those are devices. That the outlet is the box. You see what I'm saying? And when
Mm-hmm.
you got a panel board, that panel board's not an outlet. Okay, it's an
Okay.
enclosure that is housing all your different devices. And all you got to do, if you look at that breaker. What is that breaker? It's a disconnecting means. Is that correct?
Oh, yes, sir.
Sure, just like a switch. Well, when you pick up a disconnecting means it says a device, a group, it's a device or a group of devices. Okay, well, if
Yeah.
that panel board's a group of devices, and you go pick up a device, it shows a disconnecting means, switch, receptacle, circuit breaker, all these different ones. And that's what I'm trying to say. It's not an outlet. And for them, I've heard them come in and say, oh, well, if I take the receptacle, put it in there at the receptacle outlet, that's all one part. And therefore, the receptacle is the receptacle outlet. No, it isn't. Okay. I could very easily take and put a switch there. Okay. I could do all kinds of stuff there. And for them just to go ahead and just willy nilly just say, oh, well, that's an part of the outlet, the receptacle. No, it isn't. Okay,
Dude,
the,
don't you be stealing other people's willy nillys on me, all right?
yeah,
Because there's a
willy
lot of
nilly.
other people that want to get me on willy nillys, all right? But you can't patent that, all right? It's already taken.
Now watch this. This one is where they come in. They say other than shore power. This is time back. It says receptacles other than those supplying shore power to boats shall be permitted to be enclosed in marina power outlets and the receptacles that provide shore power to the boats, provided the receptacles are marked to clearly indicate that the receptacles are not to be used to supply power to boats.
Nice.
I mean, how much more clear can this be? I mean,
Yeah.
it's going through, and when you look at the heading, it's specifically telling you receptacles. Okay.
Yeah.
And the reason they're saying receptacles is because the receptacles are being mounted in the receptacle outlet. It's not at the end of the equipment. Okay.
Yep.
And not once, I looked through this whole Article 555, not once did I see anywhere that it mentioned about any other equipment and there being a GFCI protection. It all deals with receptacles and the receptacles that are installed in where. It's
The
telling
outlet.
you, in this case, it says enclosed in what? A marina power outlet.
Yeah. So just
I
to
mean,
just to keep everyone in layman's terms, you could have two receptacles in this box, and in this outlet, and you have one receptacle outlet that's got 30 milliamps GFCI protection, and one receptacle outlet that has 4 to 6 milliamps GFCI protection. And this is basically saying you can have those encased in the same box as long as you say that that receptacle that has the 4 to 6 milliamps is not to power boats.
that's right. And if
Am
you
I
look
correct?
at this, they're very specific that it's installed in an outlet. That's what gets me. And then they have specific requirements how high above the deck surface it needs to be due to your electrical datum plane.
Yep.
I mean, all of this, and that's what I'm trying to point out to everybody. You just can't just say, oh, well, everything's an outlet. Well, if that's the case, then why do they have to be specific about the receptacles being installed in an outlet? You
Well,
see
yeah,
what I'm
and
saying?
me and you, we uncovered the one on EBSE because EBSE in the manufacturer instructions said GFCI protection is not required if you hardwire it because it said the only time GFCI protection would be required is if you cord and plug connect it, because if you go into 625, I think it was 40, 625 40 or 625 30 something, it says all receptacle outlets must be GFCI protected. It doesn't say anything about hardwired being an outlet.
That's right. And look at this. They even go a little further. They talk about boat hoists here. And it says GFCI protection for personnel shall be provided for outlets, okay, not exceeding 240 volts that supply a boat hoist installed at docking facilities. And then it tells you GFCI protected receptacles for other than shore power shall be permitted to supply boat hoists. They're telling you it's a receptacle. I mean, I don't know. I, I regress on this because everything
Yeah.
that I'm reading here is going straight in to talking about receptacles. And then when you pick up D, it talks about the leakage current measurement device. And it says,
Yeah.
where more than three receptacles supply shore power to boats. I'm going to stop right there. I don't even need to go through all this leakage current and all the information notes because it specifically says, once again, what? Receptacles.
Yeah.
Now,
And
now
what are those receptacles connected to? The receptacles are connected to a standard branch circuit which supplies one or more than three, you know, and then look at that.
yeah,
Effective January 1st, 2026, you know. See, that's the whole thing. They push this stuff out. We don't even know. Like that expiration might not even be realistic.
yeah. And that's been my whole point behind this is when you look at everything that I've talked about here, everything dealt with what? A receptacle.
Right.
And then I started at the first with the feeder about GFPE, and then I did the GFPE for shore power, and then all these other connections is where it's talking about going to where? A receptacle. It didn't
Yeah.
say anything about it. Well, it did say outlets, but it said a receptacle that was installed in a marina outlet.
Right.
I, I just don't know how much more plain that can be. And then it talks about ground fault protection. And then it says the main overcurrent device that feeds the floating building shall have ground fault protection not exceeding 100 milliamps. Ground fault
Yeah.
protection for each individual branch or feeded circuit shall be permitted as a suitable alternative. And then it says outdoor outlets, shore power outlets, and boat hoists located at floating buildings shall, looky here, comply with what? Where we started, 555.35B through C, which says they're what? Receptacles.
Yep.
I
And
mean,
what we run into here is, and this is kind of a really good way to illustrate it, James. I really like it. If you look at, like, so let's just say this building, like we were talking about this a little bit. You have like a building that, like, they're selling sandwiches or something. Now you have a hardwired AC unit out there,
mm-hmm.
and you don't have Class A protection at that building on it. But guess what you have? If for some
GFPE.
reason, yeah, if for some reason something happens, you have a 100 milliamp GFPE on that. That 100 milliamp GFPE is going to save somebody's life on that AC unit.
Sure it
So,
is.
because what happens is if you have a problem, which in the case of Bontrell Pergo, he jumps the fence, he lands on the AC unit, 100 milliamps trip, Bontrell Pergo walks home.
Mm-hmm.
You know? So a lot of people try to say that this kid would still be killed if it was a 100 milliamp overcurrent protection device. That is straight lies.
That's a lie.
Yep, I agree.
There's a reason. I mean, look at them. They allow GFPE for shore power. That's around water constantly, but yet it's not okay for an AC unit. Give me a break.
Yeah.
I don't agree with that.
I
But
agree. No, really good way to present it. I think everyone learned a lot. That was awesome. I learned a bunch. I didn't really see it with that kind of spotlight when I watched Mr. Jackson's presentation, but I think there was a different kind of glasses he was wearing that day when he made that. It was a little different. It didn't seem right
well,
to me. So I
you've got to look at the full spectrum of all those sections. You just can't assume anything. And when you look at that, and he pulls out this part, but he doesn't go back here and get the other portion of the receptacles where it says it has to be in a marina outlet box. Okay, and it specifically tells you that there's no ambiguity behind that. It specifically tells you that, and the reason it tells you that is because the receptacle is installed in where? The
an
outlet
outlet.
box. And what's so interesting, it calls it an outlet box. I mean,
Mm-hmm.
how you can all of a sudden just say, oh, well, it covers all outlets, and then you pick another outlet. And I'll say this, if the receptacle's at the end where it takes the current at that point, why is there a need to even identify an outlet box? I mean,
Yeah, it's
I'll
already
pick it
there.
up.
It's
It's
already
already
there
there,
anyway.
but it's not. And that's my whole point. And that's and I'll give the code making panel a lot of credit that put all that together, because they specifically understood that the box was the outlet that the receptacle was going into. And that's why they said the different type of receptacles, regardless if it was just for GFCI protection or GFPE, that it was connecting at a receptacle that was in the outlet box. It specifically stated that every way. So, in my opinion, it goes back to what I'm saying. Anything that's hardwired, that's a termination. There's no outlet. And I think what's happening is they're taking the definition of outlet and they're misinterpreting and misapplying it, because when you go look at other sections of the code, it specifically tells you otherwise. And it's no different than Ryan saying, oh, if I come over and I hit a disconnect for a motor and then I go to a single motor and it's a fusible type disconnect, that's a feeder going over that. No, it isn't. That's a branch circuit. It always has been. And,
Mm-hmm.
we've had it in our publications for over 30 years. Nobody's ever questioned saying that was a feeder. It was always pointed as a branch circuit. Now, all of a sudden, everything that we learned all these years and decades, all of a sudden, it's all wrong. I don't think so.
Yeah, and I think that they're trying to kind of make this blanket statement that like makes everything work in the code. And me and James, like when they first came out with this, we're like, no, that makes everything broke if you go off your thing. So that's why we're trying to go in there and put some public inputs in there. You wouldn't believe this, James, but I put an across the board exception for all GFCI that doesn't apply to anything that's incompatible as long as it's listed by UL. And then the other thing I put was an exception if it already has integral personnel protection. So I think that's kind of a good one because it's like, why do you have to go in A? Why do you have to go in B? Why do you have to go in C? Why do you have to go in D? Why do you have to go in F? Why do you have to go in all these sections? Why can't you just go right in the beginning and just put this exception in there? If you have a water cooler, they took that out of 422, but you have a water cooler that has integral personnel protection, it's exempted.
Right.
So why can't they just put that in 210 and just do everything right across the board? Why can't they just do chapter 2 and just put an exception and just be done with it? Why do we have to go all these different sections? Why do we have to go to 422 then reference back to 210? Why can't we just put it in 210? You know what? Why are they so scared of putting these exceptions in there? So
It's going to be
that was
interesting
awesome.
this next cycle.
They're gonna have some good ones. I hope a few of mine pass, but I actually hope a few of mine fail too. So scavenger hunt is on.